Hey guys, this is Einar. I hope that you're doing great today, and welcome to this tutorial where we are going to be calculating our first correlation coefficient. So that's great. The first time we are actually correlating variables with each other. Now the idea behind correlation is, it can be complicated, but basically the idea is we want to see if things vary together, if there seems to be a connection between one variable and another. Now in the case of nominal scale variables like the ones we have here, we have eye color, which is blue and brown eye color, and favorite ice cream, which is strawberry and vanilla. So we want to see if there's a difference between the ice cream preferences that blue-eyed people and brown-eyed people have. So we have a frequency table here where we've actually asked people, what's your favorite type of ice cream? And we've noted their eye color here. And now we're going to measure if there is a difference between these two categories in respect to what favorite ice cream they have. Now a good correlation coefficient for that is the percent difference correlation coefficient, and we have the formula for that right here. And to make this simpler, I've made a table here where each cell is labeled according to the respective parts they have in the formula. So you see cell B here, for example, that is located here in the formula. B plus D, well, that's going to be located here in the total, which is B plus D right there. So this part of the formula of the cells corresponds to this part of the formula. So let's start calculating this and seeing what correlation coefficient we get. We write equal to, and we select our cell B here in our frequency table, our bivariate frequency table. I choose that cell there. See, this is cell B, divided by, as seen here in this formula, B plus D, which is going to be this cell plus this cell, and that is found in this cell down here. We're going to subtract A divided by A plus C. So basically we choose our cell A right there, divided by A plus C, which we can find in this cell here. And basically that's our formula for calculating the percent difference correlation coefficient. And if I hit enter there, I remove some of my decimals, I get that we have minus 0.27. I'm going to zoom in so you can see that. What does this mean? Well, what we're comparing here is the weight between these two cells here, or between these two sets of cells here. Now depending on how many frequencies we have in these different cells, we're going to get a different correlation measure. So let's say that blue-eyed people, we asked a lot of people, and blue-eyed people really like strawberry ice cream. So let's say, I don't know, 90 blue-eyed people preferred strawberry. You can see here that the correlation becomes increasingly negative. Meanwhile, if brown-eyed people really like vanilla, let's say we get 99 people there, the correlation coefficient increases even more towards -1. So the more frequencies we have in these two cells, the more negative our correlation coefficient will become. Meanwhile, if we had an opposite situation, so we said that maybe only 5 blue-eyed people preferred strawberry, but 90 blue-eyed people preferred vanilla, this is going to go towards positive. And likewise, if we say that the brown-eyed people really preferred strawberries, we put 99 there and maybe 9 there, we can see that we get a positive correlation coefficient here. So what this measure does is it measures the weight of these two cells compared to these two cells, and then it gives us the direction, so to speak, of our correlation coefficient. But remember now that because we're on nominal scale, this doesn't really matter. The plus or minus here doesn't make any difference. What we're looking for is the size of this correlation coefficient, and the closer towards 1 or -1 we get, the stronger the correlation, which means that they vary together. There seems to be a difference between our two categories here in what type of ice cream they prefer. I suggest you continue to the future correlation coefficients if you want to understand this better. We're going to be using a few. So try playing around with these numbers, try changing their values and finding out what the change is going to be in our correlation coefficient. And I wish you good luck and have a really great day. Bye-bye.